So hello everyone, my name is Rizky Darmawan and I'll be teaching Intro to Business Statistics for this entire semester. Our class number is LA2240 for anyone who doesn't know. Next, we will discuss about the split for our lesson modules. So before midterms, we'll learn about what is statistics, numerical measures, displaying and exploring data, index number, and a survey of probability concepts, and yada. And after that, we'll learn about discrete and continuous probability distribution, and last is sampling method, along with central limit theorem, of course. And this is our class rules. You have to attend class at least 85% of the time, which means that maximal absence is 2 times. And if there are a reason why you can't attend class, and it needs to be compelling enough, such as you're sick and you got to go to the doctor, or you were hospitalized, please contact me immediately if you need to be permitted. And don't be late to class, of course, and that's standard anywhere. And because the class has to go on for 1 hour and 59 minutes, even if we finish before our allotted time, please don't leave Microsoft Teams. You'll see the reason why later, and you'll see why you want to do that later. And this is our attendance method. I'm not that strict about attendance, so I won't call attendance at inside class because that's time consuming. So attendance is only conducted once through Microsoft Teams, in which you have to reply to a word of my choice for that day. So for example, attendance, you have to reply with rocket launcher. You type rocket launcher in the chat section and you're considered present. And this is our score composition. UTS, which is midterms, is 35%, and OAS is the same as UTS, which is 35%. And then there's CAT, which is our normal scoring from tasks and other stuff. So this is taken from exercise and formula summary. What is a formula summary? You'll see later after this. So this is how you get plus points during class. Throughout my teaching experience, which is only half a year long, most of the students get a lot of great scores because of my plus points. So please be sure to abide by this, plus points rule, and don't miss it, because you'll miss quite a lot of things and scores if you don't get plus points during my class. So the first method is to answer questions. I'll ask questions during class, just from the module, and whoever can answer can get 2 points per question. And then making a formula summary gives 5 extra points for midterms and finals, which is quite good, because if you get 95 plus 5 is 100. And if you get 85 plus 5 is 90, which means an automatic A. And joining the class in its entirety, which is the entire 1 hour and 55 minutes, gives you 1 plus points per class. So for example, we have 4 synchronous classes throughout this half semester. You'll get 4 plus points immediately if you join the class in its entirety. Okay, so I'm going to switch the screen to our lesson material. Okay, so right now you should be able to see our module, which is in PDF form. This is our split between synchronous and asynchronous, and the yellow one means you guys will study independently without my guidance, with my videos guidance anyways. And the one with the white part should mean that we will meet in Microsoft Teams. So module 1, what is statistics? So you should be able after this to, have the knowledge of what is statistics just at the top of your head, and you should be able to describe the 2 categories of statistics and the types of the levels of data of measurements during here, which I will explain one by one. All right, so because this is quite lengthy, I will attempt to summarize it for you. So this is one of the important parts. In statistics, we divide into 2 categories, which is going to be highlighted in orange. So descriptive statistics means that the method of organizing, summarizing, and presenting data in an informative way. If this sounds familiar, it means, graphs or charts, and other stuff. While inferential means the method used to estimate the property of a population on the basis of a sample. This is still quite hard to understand because inferential statistics means that, for example, in a population of 100,000 people, you take a sample of 100 and you ask what's their preference on, I don't know, driving on the highway. Is it speeding? Is it driving slowly? And the majority, the majority answer, sorry, should represent the population. That's what inferential statistics meant. So basically, when you're playing with samples and populations, that's inferential. And when you're playing with charts and graphs, not really, it's not just that. There's also indexes. That's also descriptive. And the words population and sample in the definition of inferential statistics. So what are those? A population is an entire set. So you have to memorize this, words, entire set of individuals obtained from all individual objects of interest. So basically, it's everyone. Okay, everyone in a population is a population. So what if a city has a population of 100 and we take only 10 to ask a question? That's what you call a sample. So it's a portion of the population of interest. And there's two basic types of variables. There's qualitative here and quantitative. So what's the difference? So basically, qualitative is a non-numeric data. It's non-numeric. So, oh, and don't be confused about phone numbers. Phone numbers are qualitative data. And you can make percentages out of qualitative data. And when the data becomes numerical, it becomes quantitative. So basically the number of people in a room, that's quantitative. Well, the number of something, 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 that's quantitative. And quantitative variables are either discrete or continuous. This we will learn later. Because just knowing discrete or continuous, I know, will make you confused. So I'm going to attempt to describe it. So discrete variables only assume certain values and there are gaps between the values. So for example, ages 1, 2, 3, 4, 5, yada yada. And a continuous one, they assume any value within a specific range. For example, during high school, I guess you've encountered a question where you're supposed to analyze a histogram that is all connected. Well, that's a continuous variable, that they're all connected. But while the histograms that has gaps in between the blocks, they are discrete variables. So here's the summary. So there's two types of variables. There's qualitative and quantitative. Wait, I can't draw here, can't I? All right, just my luck. Okay, so two types of variables. So qualitative, for example, brand of PC, Dell, HP. You can't count them, right? They're just brands. But the marital status, hair color, you also can't count them. Oh, wait, I'm sorry. An important message just came up. And in quantitative data or variables, there's two types. There's discrete, which is separated. So children in a family, 4, 5 children. So 4 and 5, there's an in between, right? There's no 4.5 children. There's only 4 or 5 children. Strokes on a golf hole, TV sets owned. You can't own 2.5 TV sets. You can only own 1 TV set or 2 TV sets. Continuous, there's amount of income tax paid. You can make it into brackets, right? That's why continuous. Weight of a student, you can classify it also into brackets. And yearly rainfall, for example. And there's 2 types, 4 levels of data of measurements, as I've said before. The first one, the one of the lowest level is nominal. So data may only be classified. So for example, there's the numbers of a football players, make of a car. So the numbers themselves or the data themselves don't actually mean something when you add it So basically, take jersey number, for example. The number 12 and the number 13 doesn't signify anything different. They're just jersey numbers to represent the players. So ordinal data, the data are ranked. They can be ranked. So for example, you rank in a class or team standings. The Pac-10, what's a Pac-10? I don't know. So for example, I'm going to take ranks in class. So rank 1, rank 2, rank 3. You can rank them, right? But you know, there's just viewing them from ranks, you can't differentiate the difference between rank 1 and rank 2. They're just ranks. But for interval data, there's meaningful difference in between the values. For example, temperature, for example, 51 and 52 degrees Celsius, for example, you can feel the difference. But for ranks, you don't know exactly what the difference is. You know, for example, rank 1 can have average score of 95, while rank 2 can have average score of 70, and rank 3 can have average score of 65. So you don't know the difference unless you see it. But temperatures, you know exactly what the difference meant. It means a difference in temperature and a difference of 1 degrees only. Dress size also, for example, 42 to 43. And ratio, there's a meaningful 0 point and ratio in between values. So this is quite interesting. Interesting in which that it's quite confusing. But there's a meaningful 0 point and ratio between values. So, you know, you can make ratios of the values, you know, from, you know, time to time or classes to classes. So this is the perfect explanation. The lowest measurement is nominal, of course, and they can only be classified and counted. There's no particular order to the outcomes. All right, next higher level of data is ordinal, wherein data classifications, they have sets of labels and have relative values. If they have labels, it means they can be ranked. See, the relative values enables the data classified to be ranked. And the interval level, there's equal differences in the characteristics. And those equal differences are represented by the equal difference of the measurement. And the highest is the ratio level. In ratio level, data classifications are ordered according to the amount of the characteristics they possess. So equal differences in the characteristics are represented by equal differences in the numbers assigned to the classifications. So the 0 point is the absence of the characteristics and the ratio between two numbers. And the 0 point is meaningful. Okay, so problem 1.1. Explain the difference between the discrete variable and the continuous variable and give 2 examples. So that's quite easy. This is the solution. So in discrete variable, all data can take only a certain numerical values. And for example, number of people living in the town, number of students in the statistics class, number of phone calls received every day. And for continuous variable, all data may include fractions, decimals, or within a specific range. For example, amount of taxes paid, they can be decimals, or yearly rainfall, they can also be decimals. And problem 1.2. So for example, each of the following data determine whether the group is a sample of or a population. So this should be quite easy. All students listed. If it says all, then you know it should be a population, right? The GPA of a randomly selected group. If it says randomly selected group, it should be automatic in your mind to consider it a sample. And next, 45 stocks from the LQ45. So if you don't know what the LQ45 is, it's a compilation of 45 stocks. So 45 out of 45 is obviously a population. And the 5 persons who come into food junction UPHA. So in food junctions, it's impossible that only 5% came. So that should be a sample. Because out of all the people that came to food junction, you took only 5 people as a sample, right? 1.3. Identify whether these sets of data, not sets of data, identify whether each of the following are either quantitative or qualitative. So A is the type of shampoo used in the neighborhood. That should be qualitative. Of course, you can't put a number on brand. The last 4 digits of an ID card. it's quantitative because you can count it. The weights of 3 electric scooter, that's of course quantitative. And the ages of 30 second employees, you can count it also. It's of course quantitative. And the gender of every second customer is of course qualitative because male and female doesn't produce any numbers. So explain the difference between the 4 levels of data of measurements and give an example for each level. That is not here. So I am going to refer to this explanation. So, normal level is the lowest level of measurement, and there's no meaningful value. There's no meaningful, the difference are not meaningful, from 1 to 2. They can only be classified and counted. And there's no particular order to the outcomes. So the parts that are orange highlighted are quite important. So I better memorize that if that comes out in the exam, because it came out once during mine. The next higher level of data is ordinal. You can rank it. Ordinal level, the most important part is you can rank it. Interval level, there's a meaningful difference. Differences are meaningful, not a meaningful difference. And the ratio level is there is a meaningful 0 point. And you can ratio between 2 numbers are meaningful. So for example, you know what ratio between 2 numbers is meaningful is. If you don't know, I'm going to explain it. So for example, in an interval level, 100 degrees and 70 degrees. The ratio is 10 to 7. So 10 kilos to 7 kilos. The ratio is 10 to 7. But for degrees, the ratio of 10 to 7 is not quite as meaningful as the ratio between distance. In fact, you can't put any meaning on the ratio in between degrees. So yeah, because 10 to 7, that doesn't mean anything, but in a degree point of view, but in a distance point of view, 10 to 7 means that the distance of going to one part is 10 per 7 times more or less. Yeah, more than going to the other part. So that should be it for today's lesson. If you have any parts that you don't understand, please feel free to message me online. I'm usually awake until 12 o'clock. You can also ask questions about your homework, but please don't expect an answer. I meant that you can expect an explanation, but don't expect an answer, like raw, legit answers. Like I won't do that, but I'll try my best to explain the answer to you. So thank you for listening. Thank you for this first class. I'm sorry because this morning the team still hasn't been made yet. Have a good day. Thank you, everyone.